Hi, class. In this module, we're going to talk about measures of central tendency and variability. Last module, we talked about graphing data. And in this module, we're going to talk about numerically describing the data we have. How do we describe what's the center of the distribution and how spread out our scores in the distribution. So we'll be talking about numerical summaries, where last module we were talking about how to visually represent the data we have. Okay, let me try to share my screen here. Okay, so if you go to the module section in Canvas, you'll see for this week, we're going to look at measures of central tendency and variability. The assigned readings for the week, you can read Chapter 5, Descriptive Statistics, in the Kranzler text. Also have a good PowerPoint. We'll go over a little bit on central tendency and variability. And then also be sure to check out the practice exercises and my SPSS resources, which you can see here. I've linked to some extra videos that cover descriptive statistics, mean, median, and mode, and standard deviation interquartile range that are online. There's also some SPSS guides, which we'll go through, and I'll run through, run some analysis in SPSS in this video. And then also have a practice exercise linked on here that's very similar to the data analysis assignment for this module. So you can see, if you look on the practice exercise here, what it's asking you to do in the practice exercise is very similar to what will be asked in the assignment. And then there's also an answer key on here for the practice assignment. So be sure to, I'd work through the practice assignment first on my own, and then you can check yourself with the answer key here. And so all this is linked in Canvas. You can see I also have the SPSS data set on here too, which you can download, and we'll look at that in a little bit as well. So you can measure all of our assigned readings again. First, we'll just kind of go through the PowerPoint a little together. So this kind of just summarizes what's going on in our readings for the week, and just give you another overview of central tendency and variability. So basically, like I said, in this module, we're interested in describing the distribution of data we have. What is the center of the distribution? What score best represents what score is the best way to describe this, our distribution. But also, measures of variability tell us how spread out our scores from one another. And that's what we're going to learn about here. You've probably already heard of a lot of these measures of central tendency. When we talk about central tendency, we're talking about what single score best represents the entire distribution. Oftentimes, in this course, we'll often talk about what best score describes distribution, but a lot of times in practice, you'll use multiple scores or data points to represent, to describe the distribution. The most common measures of central tendency are the mean, median, and mode. The mean is just another word we have for the arithmetic average. The median is the midpoint of the distribution. It also corresponds to the 50th percentile, so what's in the very middle of the distribution. And then the mode is just the most common score. So the mean, you're probably all familiar. It's the same thing as the arithmetic average. You add all the scores in the distribution together and divide by the total number. The mean is the most common measure of central tendency. You'll see it most often reported in research. we'll symbolize this a lot. You'll see it symbolized with the Y, but you'll see Y bar. You see the bar over the top, or X bar, depending on what textbook you look at. Or you'll often see people use like M equals to represent the mean. And in this case, we're talking about the sample mean. Whenever we use Latin characters like this, or Roman characters, I forget exactly what they're called, the regular English alphabet, we're talking about samples. When we use Greek letter, excuse me, when we use Greek letters in statistics, like this is the Greek letter mu, we're talking about population parameters. So the Greek letter mu will represent the population mean. So we'll use X bar or M or Y bar for the sample mean, depending on what author you're reading, and you'll use the Greek letter mu for the population mean. So in here, there's just some characteristics of the mean. I don't think any of these are really surprising. You change your score, it'll change the mean. You see this example here. We changed 1 to 11. The mean changes. You multiply every score in the distribution by a constant. The mean will change by a constant. So here's our distribution. The mean was 6. Multiplied each score by 2. The same thing as multiplying the mean, or the average, by 2. The mean also has some other nice characteristics. So the sum of deviations of all scores from the mean. So what that means is if we took each score in the distribution and subtracted it from the mean, and then added all those deviations from the mean together, the difference would be 0. And then the sum of squared deviations from the mean. So if we took each score in the distribution, subtracted it from the mean, squared it, the sum of all of those deviations will be smaller than any other value. So if we took the median, subtracted each score from the median, squared it, and added them all together, if the mean and median aren't the same thing, then the deviations from the mean will be smaller. And this will come into play when we talk about standard deviation. This property is what the standard deviation is based on. One thing that's very important to note is the mean is highly susceptible to outliers or extreme values. So the mean's probably not a good measure of central tendency when we have a skewed distribution, for instance, because the mean is going to be pulled in the direction of the skew, or that extreme outlier or extreme value is going to pull the distribution, going to pull the average of the distribution towards that outlier. So if you look at this example here, we have 3, 4, 4, 5, and 24. So the middle value is 4, or the median value, the one that's in the very middle, where the mean of this distribution would be 8. See how the mean is pulled higher because of the score of 24? So that's one, an important property of the mean to remember. So the median, as we talked about already, is just the midpoint of the distribution. It corresponds to a percentile rank of 50. Basically, what you do is you order every score in the distribution from lowest to highest, and then you find the middle value. The median is appropriate when you have ordinal data or ranked data, and the median is also preferred when you have a skewed distribution, like we talked about earlier, because the mean is pulled in the direction of the skew. So the median sometimes will then better represent the center of the distribution, where the majority of scores are. If there's an even number of data points in a distribution, the median is just the average of those two. So here we have a distribution with 4 points. 2 and 3 are in the middle, so we average those and say the median is 2.5. Okay, the mode is the score that occurs most often. The mode is often used with nominal data. What's the most frequent score? Which score occurred most frequently? If you graph these data in like a histogram, like here, you can also think of the mode as like the hump in the graph. This graph right here, we may say is trimodal. Looks like there's 3 peaks in the distribution. If you want to get technical, some people will say the mode is the most frequent occurrence. So it looks like this may be the mode, and some may say that these are minor modes. But if you see definitive peaks in the distribution, you may want to consider, hey, this may have more than one mode. There are 3 values that are occurring very frequently here. So this kind of talks about just some properties of the mean, median, and mode. If you have a perfectly normal distribution, the mean, median, and mode will all be equal. This rarely occurs in practice. They'll be approximately equal. You don't have to expect them to be exactly the same, but they'll approximately be equal in a normal distribution. If your distribution is skewed to the left, so it's negatively skewed, remember the mean is pulled in the direction of the skew, so the mean will be lower than the median. The median is going to be higher than the mean. If the distribution is positively skewed or skewed to the right, it's pointing over here to the right, the mean, remember, is pulled in the direction of the skew, so the mean will be greater than the median. And the mode is always going to be the most frequent occurrence. So those are our measures of central tendency, or the center of the distribution. We want to know how spread out scores in the distribution are. That's what variability tells us. How spread out are your scores. And I say in here, variability is your best friend. If things didn't vary, would all be the same. A simple measure of variability is just the sample range, which is the highest score minus the lowest score. Some other textbooks define it as the highest score minus the lowest score plus 1. It's however you want to define it. So we have this distribution of data, 10, 2, 5, 6, 7, 3, 4. Take the highest score and the lowest score, so the range is 8. You don't see the range commonly used in practice. It's very sensitive to extreme outliers. And you'll mostly see people reporting, say, like the minimum and maximum of the distribution, or the minimum and maximum score for each variable. You'll see that a lot more often than you'll actually see the range reported. And another characteristic, the range is the sample range is always a biased estimate of the population range. If you think about it, the sample range can never be larger than the population range, because if we had every score in the population, then it's the only time that the sample range and the population range would be similar. But as I said, the range is rarely used. We most commonly see the minimum and maximum value reported. The interquartile range is probably one you're not familiar with. It's the range of the middle 50% of scores. So if we go back to thinking about percentiles again, the interquartile range is the 75th percentile minus the 25th percentile. It's used when you have a skewed distribution. So it's a good representation of variability for skewed distributions, because you're talking about, well, what's the range of the middle 50% of scores? You also don't typically see the interquartile range reported. You'll typically see people report the minimum value, the 25th percentile, the 50th percentile, or the median, the 75th percentile, and the maximum value. So you can see you still have the interquartile range in there, the 25th and 75th percentile. Clinical terrain is also useful for identifying outliers or cases that may warrant some extra consideration. And the common, the general rule people use is if a data point is more than 1.5 times the interquartile range, we may want to look at that data point a little more and consider, is this an outlier? What's kind of going on with this score? Variance is just the average of the sum of squared deviations around the mean. Remember, the sum of squared deviations around the mean is smaller than any other deviation around the mean. So what we're doing, if we want to compute the variance, we take each score in the distribution, subtract it from the mean, square it, and do that for every score in the distribution. This means this Greek letter sum, sigma, means to sum all of the data points in the distribution. So we're going to do that for each point in the distribution, subtract each data point from the mean, square it, add all of those together, and divide by the total sample size. Well, in this case, this is to be divided by the population size. Sample, we divide by the sample size minus 1. It's been shown that if we subtract 1 from the sample size, it gives us a better estimate of the population variance. And standard deviation and variance are related. Standard deviation is just the square root of the variance. So we would still take this formula here, and we would calculate the variance and then take the square root of the variance to get the standard deviation. And the standard deviation is the most common measure of variability. It's really used when the distribution is normal or approximately normal. It's when the distribution really isn't skewed. Typically, if you're reporting a mean as the measure of central tendency, you report the standard deviation as a measure of variability. We use the lowercase Greek letter sigma to represent the population standard deviation, and the lowercase s to represent the sample standard deviation. Notice the variance is sigma squared. So if we take the square root of it, we just have sigma, or the standard deviation. The reason we take the square root is because here in the variance, we're talking about squared units, right? Because we squared every unit. So by taking the square root of the variance, we put the score back in terms of the original metric instead of in squared units that the variance is in. So you typically don't ever see, you rarely see the variance reported. You most likely see the standard deviation since the variance is in squared units. But the variance will come into play, has some nice, useful, and beneficial properties that come into play later on, and if you take more advanced statistics courses. So here's my little blurb about a variance or standard deviation. I kind of went over that already. I also have an example in here. Here's our list of scores, here's our distribution of scores. If we want to compute the mean, we add each score together, divide by the total. So the mean score is 72, so right around here, we think that represents as a representation of the distribution. If we want to calculate the variance or the standard deviation, we take each score, 90, subtract it from the mean, 72, and so we have 18. 90 minus 72 is 18. 85 minus 72 is 13. 76 minus 72 is 4. 65 minus 72 is negative 7. Okay? You notice if we sum all these deviations from the mean together, we get 0. That's that property that sum of deviations from the mean equals 0. So then what we do is we take each deviation from the mean, square it. 18 squared is 324. 3 squared is 9. Negative 2 squared is 4. So to get the variance, we take each deviation from the mean, square it, sum them all together. We get 1604, and then we divide by the sample size minus 1. So we take 1604 and divide it by 7. The variance of this distribution is 229. That doesn't seem very intuitive to us. So we'll take the square root of 229 and you get 15. So the average score of this distribution here, well, of this column, this first column won't let me highlight just yet, of this is 72. And then each score is on average about 15 units from the mean. So that's what the standard deviation is telling us, is how varied scores are from the mean, how spread out are scores from the mean. So that's an example of calculating the variance in standard deviation. So how do I know which measure to use? That's a good question. So first, we only care about variability when we have quantitative data. So if we have nominal data or categorical data, we don't care about how spread out the scores are, right? Because the scores that represent those categories are arbitrary. So when we do have quantitative data, we want to think about what type of data we have. So if our data are approximately normally distributed, so if the data aren't skewed, then sample standard deviation is a useful measure of the spread of scores. If the data are badly skewed, the standard deviation gives us the deviations from the mean. So if the distribution is skewed, the mean's not a good measure of central tendency. So deviations from that measure of central tendency may not be useful as well. So if the data are skewed, we may want to consider looking at another measure of variability like the interquartile range. So some properties of standard deviation, standard deviation is always positive. It's either greater than or equal to 0. If standard deviation is 0, that just means that every score in the distribution is the exact same. We have 7, 7, 7, 7, 7 in the distribution. So the greater the variability in scores, the larger the standard deviation will be. The smaller the variation in scores, the smaller the standard deviation will be. Seems reasonable, right? Standard deviation has some nice properties in terms of the normal distribution. If your distribution is normal or approximately normal, around 68% of scores will fall within one standard deviation of the mean, either on the positive or negative side. If the distribution of scores is normal, then about 95% of the data will fall within 2 standard deviations of the mean. And then nearly all of the distribution will be within 3 standard deviations of the mean. So about 99% of scores will be within 3 standard deviations of the mean. So the standard deviation has some nice properties that relate it with the normal distribution that make it a very useful measure of variability for us when our distribution is normal. I also have linked in here some practice exercises. If you open this in PowerPoint and look in the notes section, the answers to these practice exercises are in there. So that's kind of a quick overview then of the PowerPoint for this week. Also linked in Canvas are some SPSS guides. So if you look here, this shows you how to run a descriptive statistics command in SPSS. You've got to analyze descriptive statistics, descriptives, and then you would bring over which variable you want descriptive statistics as, and then you can choose which ones you would like, and then here's your output, and I have annotated what each of the values mean. I don't find the descriptive statistic procedure in SPSS that useful because you can get all the same stuff from the frequency procedure. So if you're going to analyze descriptive statistics frequencies, bring the variable over you want. If you click the statistics box here, you can get all your measures of central tendency, all your measures of variability here. You can even get measures of the skewness and kurtosis of the distribution. You can get percentile values and get those quartiles we were talking about, like the 25th and 75th percentile. If you want specific percentiles, you can click this button here. You can also get charts in there. You can get a bar chart, a pie chart, or a histogram. And then if you look here, I've also annotated your output there as well too. Let's look at this real quick in SPSS. So if you open that practice data set, you'll see there are 3 variables in here. One represents weight. One is, I believe, where they want to go on vacation. The third one is housing values. If you look, weight and home prices are continuous variables, and they're measured on an interval ratio scale. So the values are meaningful. Vacation is a nominal variable. So what we did was we assigned values. 1 equaled Hawaii, 2 equals Cabo, 3 is the Bahamas, 4 is New York City. I believe these correspond to the practice problems here. And I believe it says, Marianne's planning on going on summer vacation, but she can't decide where to go. She's narrowed it down to these 4 places and put a poll on her Facebook site to let her friends help her decide where she should go. And so here are the data then from that analysis. So, we just arbitrarily assigned Hawaii as 1, Cabo 2, Bahamas 3, New York 4. You could have used any values to represent these categories. Hawaii could have been 4, Bahamas could have been 33. You can use whatever numbers you want. This is just you telling SPSS, hey, 1 equals Hawaii. All right. Just a quick rundown on how, let's say, we would get some descriptive statistics on our measures of central tendency and variability for this data set. We click on Analyze, Descriptive Statistics. And like I said, I like using the frequency command. You can get it all from there. We take our weight variable, highlight it. We can click this button to bring it over, or you can take it and drag it over wherever you want. If we want to get some statistics, we click over here on Statistics. We can get quartiles for our data. So we want to know what's the 33rd percentile. We could type in 33 and click Add, and we'll get the value that's equal to the 33rd percentile. We want to get the mean, the median, the mode. Some just adds all, what's everything in the distribution added together. So what would be the total weight if that value is important to you. We get the standard deviation, the minimum, the maximum value, the variance, the range, whatever you think is might be important. We'll just get the standard deviation. If you wanted measures of skewness and kurtosis, you could also request those as well. If you want a chart, weight is an interval ratio variable, so a histogram may be appropriate, and we can also lay a normal curve over the top of the histogram. So let's click OK. Let's see what we get out here. Here's our output. So there were 43 valid cases on here. The average weight was 131.2 pounds. The median weight was 130 pounds. The most frequent weight, or the mode, was 130 pounds. The standard deviation was about 32 pounds. So each each weight varied from the mean by around 32 pounds. Here we get our the 25th percentile. So about 25% of scores are at or below 109 pounds. 75% of scores are at or below 157 pounds. That's how you can interpret the percentiles. Here's just a frequency, just a frequency chart. So you just list one person was 73 pounds, two people were 88 pounds, kind of how you can read that. Three people were 130 pounds. So, and then here's our histogram. It looks like it's nice and normally distributed, right? We have the normal distribution over here, but we get a nice distribution. If you notice that our mean, median, and mode were all approximately equal, right? And that occurs in a normal distribution. Also, the skewness coefficient and kurtosis coefficient kind of give you an idea of the skewness and kurtosis of how pulled in one direction is the distribution from one another, and then how peaked is the distribution is what kurtosis gives us. And the general rule of thumb is if like the skewness coefficient is greater than 1 or less than -1, we may want to look a little more into it to see what's going on. If it's greater than 1, then it's saying the distribution is more positively skewed. If it's less than -1, it's saying the distribution is negatively skewed. And same thing, kind of same rule of thumb with kurtosis. This negative value is saying this distribution is a little more flatter than a normal, a perfect normal distribution. That's what these compare them to, is what a perfect normal distribution is going to be. These distributions really approximately normal. For all intents and purposes, we could treat it as a normal distribution. If you want to do the same thing in the descriptives command, you can analyze descriptive statistics, descriptives. You can bring your variable over. I don't think there are any. Yeah, you can choose which options you want. They have some similar features, but I think you get a lot more out of the frequency command. So if you see here, same thing, total, the minimum value, the maximum value, which you could also get out of the frequency command, the mean, the standard deviation, and there's your skewness coefficient again. Don't worry about the standard error right now. Let's see. So it's pretty easy, I think, to run these in SPSS. If you were to enter these data into SPSS, that's also pretty easy too. We'll start over here on the variable view tab. And so we were wanting to enter in the weight. We'll just say we have a second weight value. We would type in the variable name here, click on data view, and then we would just type in our values, 76, 88, 91, whatever it is. And, it sort of works like Excel in that sense. If you go back to variable view, you can change the way things look in there. We don't want these to have any decimal places. We do want decimal places to show up. We want to give it a label, like wait after 2 weeks. I don't know. If it is a nominal variable, this is where we would enter our categories. We would say value 5 equals Chicago, and we would add if we wanted something like that. If we had a certain, we use say -9, and that was to represent we're missing a value on that person, we could add that. We could tell SPSS in here that -9 values mean we're missing that. If you want them aligned to the right or to the left side or centered, you can do that. You can tell if the scale of measurement is SPSS calls interval ratio variable scale. So is it nominal, ordinal, or interval ratio? And then you can see where you left align this. So it's just how, most of this stuff in here, decimal points, the align is just really the look of it. What's really important to put in here is you'll probably want to label all of your variables so you know what it means. If you have a nominal variable, you want to put in value so you know what those categories stand for. And then you'll probably also want to put in the scale of measurement in here. Sometimes SPSS will warn you, you try to run a procedure like or run a t-test, say on a nominal variable. Sometimes SPS will warn you like, hey, this variable is nominal. You can't do that. Other times it doesn't. It's very inconsistent in the way that it does that. But don't forget to look at the practice exercises that are on Canvas. Like I said, it's very similar to the data analysis assignment. And then don't forget there's the data set for it and the answer key. And so we'll have, in this module, we have a data analysis assignment and then a quiz on the measures of central tendency and variability. So that's it for this module. If you have any questions, post them to the message board or shoot me an email. Thank you and have a great week.